Hello, everyone. Welcome to episode 2, Math Behind Machine Learning. In episode 1, we guessed a number stored by the machine. There we coded rules, but today the machine learns on its own. We will start with a simple example. We have size of each house and a price for them. But for a new house with a different size, we want to predict its price and we don't have them yet. Before we code, let us see the math behind it. Same like the guessing game. If it predicts higher, we ask it to go lower, and vice versa. The difference between the actual predicted value and the actual value that was is called an error or a loss. Too many jargons? Don't worry. Let us see with a well known example that we have. Right now, this is a slope equation which you might have learned during your higher schools. So, y is the output. In our case, it's the price of the house. X is the size of the house. So, what is M and C? M is the slope, the rate of change of the value, and C is a constant. If it's not starting at the zero value, that value becomes the C value here. Here it starts at C, 3, that becomes the C value. Once we get the difference or the error value, we go back and change the M value and the C value in the equation and run it again and again and again until we see that predicted value and the actual value are close to each other. So we have an example here, X, Y, right? Let's run this for now. What are we trying to do here? Let's define some variables here. Let's define some variables here. Run random guesses. The slope is defined, the constant is defined. LR and epoch, what are they? Learning rate and epochs. Learning rate is, like I told you, once you know the error value, you go back and you change the slope value and the constant value again and again and again. So, how big do you want to change the number to? Right, if you multiply this learning rate with the slope and the constant and reuse it in the formula, it cannot be too big or too small, or else your process will either take too long or you would actually cross the expected value and go beyond and you miss your station basically. And epochs, how many times do you calculate the error and go back and do the same process? So these two are very important variables while calculating ML. Right now, we are not using any machine learning modules in Python. We are writing our own code. Let's see how it happens. Right. So just for 10 times, let's see how it's going to come. Okay. And like I told, the MXC formula, y predict, and then error function. What is an error function? Like I said, you are subtracting the predicted value with the actual value and knowing what's the error here. And here, like I said, you are changing your slope value and your constant value. Don't worry about the formula for now. Just understand that M and C are being changed according to the errors that we get. And again, they are reused in the formula. Again, they are reused in the formula. All right, this is fine. So now let us plot X values and the Y value and see how they're responding. Oh, that's bad, right? Look at the X value and the line is nowhere closer to the reality. So let us spike up our epochs and see how it works now. Oh, this is much better, right? Let's spike it up even better. Okay, not much of a difference. Let's make it 10,000. Ah, this is perfect. This is perfect. But do you understand you had to run it 10,000 times, which is computationally not very good. Instead, if I can reduce or if I can increase the learning rate and try, let's see what happens. This is good. This is good, right? So with just 1,000 times, see, now you understand how to correlate the x and the y value with a regression line. So as we change the epochs and learning rate, you see how the prediction line changes. Do it until we see a confident line. There we go. So that's all for today. See you again soon with the types of ML.